right, hello again, guys. So this is the second video for our topic on decalcification. Okay, so I will be starting off with the different factors which are to be considered when we are trying to or when we are performing the process or the step past tense, ma'am. Okay, the step in tissue processing, which is your decalcification. Okay, so what are some of the general considerations that we have to take note of when we are performing routine acid techniques? Okay, so of course, first and foremost, we have to consider the thickness of our specimen. Okay, so for dense or hard bone samples or specimens, they have to be 2 to 5 millimeters thick. Okay, so again, um, take note that we don't want to prolong the process of decalcification. Why? Again, this is because for your acid decalcifying agents, they are particularly injurious to our tissue sample. Specifically, the portion of your tissue that is affected would be your ground substance or your extracellular matrix. Okay? And I have emphasized already the significance of your ground substance or your extracellular matrix, particularly for our bone tissue. Okay, so they're very important in order for us to maintain or to preserve the architectural pattern and yes, the architectural pattern of your samples, of your tissue samples. In this case, we are emphasizing on the amount, okay, of your ground substance or your extracellular matrix in your bone tissue. Okay, so that's why contact with your acid decalcifying solutions should be minimized. And so, what is one of the most effective ways by which we can minimize the contact of your acid solutions to your tissue samples? We have to make thinner. Okay, we have to make your specimens thinner. Okay, so since your dense or hard bone samples are harder to penetrate, you have to make it thinner as compared to your softer tissues. Okay, so for softer tissue samples, the required thickness is 4 to 6 millimeters. Okay, so we have 4 to 6 millimeters. All right. Another factor that we have to consider is the duration of the decalcification process. So the duration of your decalcification process, this is dependent upon the density or the compactness of your samples. Okay? So ideally, we have to perform or we have to complete the decalcification process within 24 to 48 hours. However, of course, for our dense cortical bone samples, again, ano ulit pag sinabi nating cortical? So cortical refers to your compact bone tissue. Okay? So for our dense cortical bone tissue, um, since they are harder to penetrate, so it would require a longer duration. So in this case, the required duration for your dense cortical bone tissue is at 14 days. Okay? So for the temperature at which you have to perform your decalcification process, so routine or normally, okay, normally, decalcification process is performed at room temperature. So in decalcification, the room temperature range is different from the range which I gave to you in fixation. So in decalcification, the range of room temperature is 18 to 30 degrees Celsius. Okay? That's why when I was discussing fixation to you guys, I mentioned that in fixation, that's the room temperature, 20 to 22 degrees Celsius. But in decalcification, the room temperature is 18 to 30 degrees Celsius. Okay? So also in decalcification, you have to be very careful when you are going to perform this process at higher temperatures. Why? Because, yes, of course, the decalcification process will be accelerated if you increase the temperature. However, it will compound, okay? Or it will impair the staining even more. So the staining, which is a consequence of performing the decalcification process, will become worse. Okay, so it will make the staining of your structures worse if you are going to perform decalcification at higher temperatures. Particularly, you have to take note of the following temperatures. We have 37 degrees Celsius, okay? So at 37 degrees Celsius, there is an impaired nuclear staining with your Van Giesons. So if you can still remember your human histology, Van Giesons is a staining technique that we use for collagen fibers. Okay? Yes, for collagen fibers. So, when we say the nucleus, baka mamaya isipin nyo, ma'am, wala namang nucleus yung collagen. Yes, that's correct. Correct naman po. However, when you are going to stain your tissue sample, it's not just your collagen fibers which are actually found, right, in your tissue sample. So, of course, your tissue sample will also include the different cellular elements which are found in your tissue sample. Okay, and the nuclear staining of the cellular elements which are found together with your collagen, okay, they are the ones which are stained in your Van Giesons. All right, ayan. So another, at 37 degrees Celsius also, there will be a reduced effectiveness of your trichrome stain. I think nasa ano ninyo to? Yes, meron. Nasa module po ninyo ito. Okay, so at 37 degrees Celsius, there would be a reduced effectiveness of your trichrome stain and your PAS. Okay, so again, what is PAS? Yes, correct. We have your periodic acid shift. Okay, yes. And then, take note. Okay, take note class. At 55 degrees Celsius, okay, at 55 degrees Celsius, your tissue will undergo complete digestion within 24 to 48 hours. Okay? So what's the significance of this? Remember that the ideal decalcification duration is 24 to 48 hours. However, if you are going to perform the decalcification process at 55 degrees Celsius for 24 hours, pagbalik mo, wala na. Okay? Pagbalik mo, wala na yung tissue bes. Okay? Ayan. So we have to be very careful because it will enhance, okay? Yes, it will enhance the injurious effect of your acids in your tissues. So there will be complete digestion, okay, of your tissue sample. Pagbalik mo, nawala ka lang saglit, isang araw lang. Pagbalik mo, wala na siya. Okay? Yan. Sam, hello. Okay, in English, if you are going to perform decalcification at 55 degrees Celsius, and when you go back after 24 hours, it's gone already. Right? You just left for 24 hours for approximately 1 day. And then when you came back, everything is gone. Okay? Your tissue sample is already gone. It has undergone complete digestion already. Alright? So be careful, guys. Do not just leave. Okay? Because if you leave, when you come back, there's nothing that you will ang hirap mag-English. Okay, when you come back, um you will lose your tissue sample. Okay? So in Tagalog, pag umalis ka, baka pagbalik mo wala na. Wala ka nang babalikan. I don't know how to translate that in English. Sorry, Miss Sem. Okay? You have to learn more Tagalog. Alright? So be careful when performing the decalcification process at higher temperatures because it will, okay, make the consequences worse. Right? Ayan. So, other factors that you have to consider would be the solution that is utilized. All right. So, in decalcification, we have to we have to look at two characteristics of your solution. Number one, how concentrated is your solution? Number two, is the acid a strong acid or is it a weak acid? Okay, so our knowledge in MCHOC, yes, Ma'am Roberts, okay, babalik yan, kailangan nyo yan sa histopath. Ako ha, yan, I hope you can still remember. Hi, Ma'am Roberto. Alright, strong acids versus your weak acids, okay? So what would be the effect of these characteristics of your solution in the decalcification process? Okay, so first, let's look at the concentration of your solution. Okay, so the concentration of your solution is directly proportional to the decalcification rate. That means the more concentrated your solution is, the more rapidly it is able to decalcify. Okay? The problem with the use of concentrated solutions is that they are more detrimental to your tissue samples and they will have a worse effect on the staining of your tissue sample. Okay, yan. So concentrated solutions, yes, they will hasten the decalcification process, but they are more detrimental to the staining and to your tissues also. Okay? So apart from that, another characteristic that we have to consider as for the acids that we are using in the process of decalcification is whether they are considered to be strong acids or weak acids. Okay? Strong acids, what are examples of this? In general, okay? In general, strong acids, gaano ka-strong yung boses ko. Okay. So, in general, what is our rule from our MCHOC? Okay. So, strong acids class, these are usually your inorganic acids. Okay. So that you would be able to this thing that I am explaining now, it will enable you to remember characteristics of your decalcifying agents, okay, particularly your acids. So you have to be familiar with this. Strong acids, they are usually inorganic acids. So what are examples of inorganic acids that we use in the laboratory? Like for example, in your MTOC. Okay, can you give me one? Okay, yes, that's correct. We have your sulfuric acid, right? What else, guys? Come on, come on, come on, guys. Okay, yes, correct. We have your nitric acid. Wrong spelling tuloy ako. Okay, and then what else? Okay, very good. We have your hydrochloric acid. Okay, let me just remind you about the characteristic of your strong acids. When we say strong acids, if you are going to put them in an aqueous solution, or yes, if you are going to look at their dissociation, okay, at their dissociation, your strong acids will dissociate completely into the elemental forms, right? Into the elemental forms that make up your strong acids. So say for example, if we consider your hydrochloric acid, Okay? When your hydrochloric acid dissociates, it will dissociate into hydrogen and your chloride ions. That is a characteristic of your strong acids. They dissociate completely into their elemental forms. Okay? In contrast, when we talk about your weak acids, I think this is more on your analytical chemistry, right? Yes, because I also taught analytical chemistry before and it's very difficult. Okay, so anyway, your weak acids, they are usually organic acids. Okay, they are usually organic acids. So they are referred to as weak acids because they do not dissociate into their elemental forms. Right? Like for example, if we consider your formic acid, hindi naman yan mag-dissociate into hydrogen ions. Yes, some of it some of your hydrogen ions will dissociate, but it will not dissociate completely. Okay? And so they are referred to as your weak acids. And we have your organic acids as examples of your weak acids. Okay? So examples of weak acids would include your formic acid. What else? Citric acid. Okay? Yun lang ang alam ko. Okay? So yan. So formic acid, citric acid, oxalic acid. Okay? Ano ba yun, oxalic? Sure pala. Okay. Yes. So these are examples of your weak acids. Okay. The problem, class, with our strong acids is that they are more damaging to our tissue antigens. Okay. So if they are more damaging to your tissue antigens, your strong acids cannot be utilized for immunohistochemical staining. Okay? So they cannot be utilized for cytochemical staining, for example. Okay? Because from the term itself, immunohistochemical, our basis would be antigen-antibody interaction. So if you have lost your antigens due to the use of your strong acids, where will your antibody interact? Or where will your antibody, yeah, tama. To what structures will your antibodies react? Wala. Because you have lost your antigens already. So that's why strong acids are not used if, for example, you would like to perform immunohistochemical or immunocytochemical staining later on. Okay? Because um, there is the loss of your tissue antigens. Okay? So apart from that, your strong acids may be totally lost if you make use of this type of reagents for decalcification. Remember, what is the nature of your enzyme? Okay, yes, that's correct. Your enzymes, they are actually proteins. They are protein in nature, right? And I think this is in your biochemistry. Okay, in your biochemistry, the denaturation of your proteins may be brought about by their exposure to your strong acids. So enzymes, being protein in nature, they will be denatured by your strong acids. Okay, so I think you also discussed this in your clinical chemistry too, right? Yes. So of course, if your enzymes undergo denaturation, yan, their activity will be lost. You will not be able to demonstrate the activity of a particular enzyme. All right, so that's why strong acids, do not use it for immunocytochemical staining. Do not use it also for, or if, for example, you want to demonstrate the activity of your enzymes later. All right, yan. So since the acid decalcifying solutions that we use in this step of tissue processing, they can be injurious to our health, to our tissue samples. Okay, they can bring about consequences which are unfavorable for us. So what can we do in order to mitigate, okay, the harmful effects of your acids? So we use your additives. All right. So that's why I also included it as one of the factors that you have to consider. Okay. So in order to protect your tissue samples from the injurious effects or the damaging effects of your acid solutions, you can incorporate additives in your solution or in your formulations. Okay? So, additives which are oftentimes utilized for our acid decalcifying solutions would include your alcohols and buffers. Okay? Alcohols and buffers. All right? Ayan. So specifically, the role of your additives is to protect your tissue samples from any damaging effect which is brought about by the use of your acid decalcifying agents. Okay? However, take note, take note, okay, that your additives will slow down the decalcification process. All right? So that's why in performing decalcification, you have to consider all of these factors. What do you want? Okay? Ano ba ang gusto mong mangyari? Ha? Okay? Ano ba ang gusto mong mangyari? What are you after? What is the purpose of your decalcification process? Okay? What do you want to achieve? Do you want the decalcification process to be fast because you need to provide an immediate diagnosis? Or do you want to protect your tissue samples regardless of how long you are going to perform the decalcification process? All right? So all of these things, all of these factors, you have to consider them. Okay? Yan. So your additives, it will protect your tissues, but it will slow down the process of decalcification. Okay? Another factor that you have to consider would be fluid access. Okay. So when we say fluid access, you have to ensure that all parts of your sample, it has to be in contact with your decalcifying solution. All right? So that means, okay, ano ba ako record? Yes. That means, si ma'am naman kanina pa nagsasalita, hindi alam kung naka-record. Kasi nga, naano na ako dito sa, ano na to, video na to. Okay, so that means, if for example, this is your container, okay, if that is your container, and then we have here your fluid, okay, we have here your fluid, all right, you have to ensure, hindi, taasan pa natin, okay, yan. So we have here your fluid, your decalcifying solution or fluid. Okay, so if this is your container together with the decalcifying solution, you have to ensure that your sample is suspended. Okay, suspended po. Not just immersed, but it has to be suspended. Okay, and sabi sa atin ng ating mga references, according to our references, you have to suspend at the upper portion of your fluid. Okay? So that means if this is your setup, right? If that is your setup, you have to, okay, you have to suspend it in the upper portion. Okay? It has to be suspended in the upper portion of your jar or your container. Okay? Why? Because if you are going to look at how your calcium salts, how are your mineral deposits removed from your tissue sample, it is by way of precipitation. Okay? So, the different salts, um, that are removed from your ano pangalan nito? From your tissue sample, some of them will tend to precipitate. Okay? And so, your sample, it cannot be in this portion. Why? Because we all know that your precipitates will settle at the bottom portion of your container. Right? So it will settle here at the bottom portion. So that's why your precipitates, they cannot come in contact with your sample. Otherwise, some of these precipitates may be incorporated in your tissue sample later on. So in order to prevent that, you have to suspend your tissue sample at the upper portion of your container or your jar because the dissolved salts will sink at the bottom of your container. Okay? Yes. So another important factor that you have to consider would be the changing of your solution. So for the changing of our solution, so it has to be changed once or twice a day. So this one, it depends, it actually depends upon the type, okay, the type of decalcifying agent that you are going to perform, or that you are going to use. For acid decalcifying solutions, the solution has to be changed once or twice a day. Okay, why? Because if you are using your acids only as your decalcifying agent, your acids, they have to perform two important things. Number one is to dissolve the mineral deposits which are present in your solution. Number two, they have to react. Okay? They have to react, or they have to interact with the dissolved calcium salts or mineral deposits. Okay, so that's why in the process of decalcification, your acid solutions are actually being used up in a chemical process. So that means the effectivity of your acid solutions decreases over time because they are being used up in order for you to remove your calcium salts or your mineral deposits. Thus, their effectivity, again, I will emphasize the effectivity of your decalcifying solutions decreases over time. So that's why you have to change them once or twice a day. Okay? Yes, all right. So other factors that you have to consider, we have the volume of your decalcifying agent. So there are actually two volumes which was mentioned by Gregorius in her book. The first one, there is really a quantity. Okay? So actually it's not Gregorius pala the other one. This was mentioned by Gregorius. So the volume of your decalcifying agent, acid decalcifying solution, it has to be 20 times the volume of the tissue sample. Okay, so it has to be 20 times the volume of the tissue sample. So if, for example, okay, no value was given among the choices, you look for the term generous volume. So I repeat, if for example, there is no quantity that was given in your or in the choices, okay, so you look for the term generous volume. Okay, so generous volume of the decalcifying solution should be used. Okay, yes. So apart from that, we also have to consider the following. We have the presence of agitation. So again, just like what we have discussed in your fixation, mechanical agitation, okay, or moving of your tissue in the solution. So this will influence the fluid exchange that will take place in your tissue sample. So in particular, agitation will increase the rate of diffusion of your acid solution molecules. Thus, it will speed up the decalcification process. Okay, so there are actually several ways by which we can uh, we can we can agitate. Okay, we can agitate your solution, um, or yes, we can agitate your solution or your tissue. So we can yes, we can make use of low speed rotation. We can make use of rocking. We can make use of your mechanical stirrer. We can introduce air, okay, bubbles into your solution. That is also a form of agitation. We can also we can also make use of sonication or sound waves. Okay, sonication, this has been incorporated in some of the machines that we use in histopath. The only problem when it comes to the use of sonication or agitation is that it will result to vigorous agitation. Okay? Yun lang ang problema sa sonication. So, it causes vigorous agitation of your solution, okay, or your sample. All right? Another factor that you have to consider is the removal of your decalcifying solution. So for the removal of your decalcifying solution, again, this is very important, guys, right? I've already mentioned you have to completely remove your decalcifying solution, especially if your decalcifying solution is an acid. Okay? So the removal of our decalcifying solution, this is actually performed in two instances. Okay? Or it may be performed in one of two instances. Or kung talagang, if you really want to ensure that your decalcification is completely removed, okay, so you can perform it twice. All right. So it can be performed after decalcification. Okay, yes, that's number one. You can perform it after decalcification, or you can also perform it prior, okay, prior to staining. Because again, we go back. What step is greatly affected by decalcification? It's stain. It's the staining step in your tissue processing. So if you want to be sure, kung sigurista ka, what is the English of sigurista? Sigurista, Miss Sem, means you want to really be sure about it. Okay, so if you really want to be sure that all of the decalcifying solutions are removed, okay, and to ensure that staining will not be affected, you can perform the removal of your decalcifying solution prior to staining. Okay, so another would be another would be and the last one, we have the use of microwave and electrolytic methods. Okay, so for the use of microwave and electrolytic methods, of course, they will make the decalcification faster. Okay, so they will make the process faster. However, of course, since you are introducing microwave and electricity into your setup, so a consequence of these methods would be the production of heat. All right. So while it is true that they are capable of making the process faster, you will be introducing heat to your setup. Okay. And we all know that when it comes to increasing the temperature of the environment or of your setup for decalcification, you have to be very careful because an increase in temperature will enhance also the injurious effects or the detrimental effects of decalcification. Okay, so those are the different factors that we have to consider in performing the decalcification process. All right, so before we go to the specific methods or agents that we use for decalcification, I would just like to differentiate the term decalcifying agent and then decalcifying methods, okay, as mentioned in your modules. So when we say decalcifying agents, these are the solutions. Okay, and there are two decalcifying agents that we use in the laboratory. We have your acids and your chelating agents. Okay, so yun lang, dalawa lang. We only have two agents, decalcifying agents. Acids and your chelating agents. Okay, in contrast, when we talk about your methods, these are the procedures that we perform in order to carry out the decalcification process or the decalcification step. Okay? Yes. So, balik tayo kay decalcifying agents. What are the different characteristics of a good decalcifying agent? Number one, of course, it should be able to remove calcium salts or mineral deposits from tissues completely. Okay? Another, it should not produce considerable destruction of cells and tissue components. Although there will really be destruction of your cells and tissue components, it should not be considerable. It should not be significant enough. Okay? It should not be significant enough that you are not able to view anything anymore under the microscope. All right? It should not also adversely affect the staining capacity of the cell, particularly your nucleus. So again, take note of the term of the term that is in that sentence, adversely, not adversely affect. Because there will really be an effect as to the staining of your tissue components. However, it should not be significant. Okay, also, it should not be significant. Particularly, we are after the effect of decalcification in the staining of your nucleus. Okay? Yes. So in contrast, when we say decalcifying methods, these are the different procedures that we can perform for decalcification or demineralization. So what are the methods? You can use your acid, the use of acids, okay? The use of your chelating agents. And of course, we have two additional methods which would require your acids plus an additional material or equipment. So these are your ion exchange resin and your electrophoresis. Okay? Because you cannot carry out ion exchange resin and electrophoresis without using your acid decalcifying solutions also. Alright? Yan. So, apat yun ha. Apat. Okay. So, I think I will... Yes? Can I end the video here? Or no? Wag na. Ituloy-tuloy na lang natin. Kasi sayang. Alright. Yes, so let us discuss the different acid solutions that are utilized for the process of decalcification. Okay, so what is, again, the basic thing that you have to remember with the use of your acid solutions? They are injurious to the organic ground substance or your extracellular matrix of tissues. And if you are going to make use of your acid solutions for decalcification, immersion should not be prolonged beyond 4 days when possible. Okay, so I repeat, immersion should not be prolonged beyond 4 days when possible. Okay, so the use of your acid solutions, it is actually considered to be the most common and fastest for routine processing of large amounts, especially if you are handling large amounts of bony tissue samples. Okay? So one of the acid solutions that we use in histopath is your nitric acid. So actually, there are several formulations of your nitric acid, okay, which we will be discussing in a short while. So first, let us look at your nitric acid. Okay, nitric acid. Yan. Siya pala. Sorry. Na-excite ako. Okay. I think I mentioned na sa bagay, acid solutions naman are the most common. Okay? So, your nitric acid pala is guys, naka 41 minutes na ako. Ayoko namang ulitin na naman tong video. Okay, sige, i-correct ko na lang po yung sarili ko. Alright, so your nitric acid, it is considered to be the most common and fastest for routine processing of large amounts of bony tissue. Okay, yes, especially if your laboratory is handling a lot of bone samples. So in particular, your nitric acid, it can be used as a simple solution with a concentration of 5 to 10%. Okay, 5 to 10%. Ayan. The additives that we use, okay, the additives that we use for your nitric acid are the following. We have formaldehyde, alcohol, and chromic acid. Okay. The one characteristic of your nitric acid that we have to consider is that it is considered to be a rapid decalcifying agent. Okay? So, for rapid decalcifying agents, one disadvantage that they have is that although they are considered to be rapid, they inhibit. There is a probability that nuclear staining will be inhibited. Okay? And apart from that, since they are considered to be the rapid since this rather is considered to be a rapid decalcifying agent, it is also injurious, okay, to your tissue samples. Alright? Basta, ang tandaan ninyo, okay, you have to remember that if a particular, itong general rule ha, if a particular decalcifying agent is considered to be rapid, it will, okay, it will have a more damaging effect to the tissue. It will have a more detrimental effect to the staining of your tissue structures. Okay, that's the general rule for our rapid decalcifying agents. Okay, ayan. So, in order to prevent or to mitigate this particular effect of your nitric acid to your tissues and to staining, we incorporate the use of your additives. Okay? So, just like what I have mentioned, the following additives are utilized for your nitric acid solutions. We have your formaldehyde, alcohol, and your chromic acid. Okay? the the okay, before we go to the washing of your nitric acid, may I just also mention that your nitric acid is considered to be a strong acid. Okay, and so what can we say about its application in the laboratory? You should not use nitric acid for your enzymes. Okay, you should not use your nitric acid if you are going to perform immunohistochemistry or immunocytochemistry later on. Right? Because I discussed already, your strong acids, they tend to denature your enzymes. They tend to damage the antigens which are present on the surface of your cells and other tissue components. Okay? So as for the preparation of your nitric acid, always use a fresh stock solution. Why? Because old nitric acid, it is even more damaging. Puro ka damage, ma'am. Oo, kasi ganun talaga dito sa decalcification, guys. Okay? So, in decalcification, puro damage talaga po dito. Okay? In fixation, puro penetration naman doon. Dito, puro damage. Okay? So, yon. Old nitric acid, it is even more damaging to your tissue sample. Okay? Yes. So, that's why you have to always use a fresh stock solution of your nitric acid. Okay? Yes. And And for the washing out of your nitric acid, always use alcohol. Okay, do not use water because later I will explain. All right. The washing of your nitric acid, you have to make use of 70 to 90%. Sabi niyan dyan sa inyong module. Washing of tissue samples decalcified using your nitric acid. The acid is removed by using 3 changes of 70 to 90% ethanol. Okay, so I repeat, washing of your tissue, you have to remove the acid by 3 changes of 70 to 90% ethanol. So for our slides, okay, yes, washing of slides. Can you perform removal of nitric acid before staining? Yes, you have to wash your slides or your sections in doing that. Okay. So in the washing of your slides, all right, before you place it in 1% aqueous lithium carbonate for 1 hour, you have to bring your slides to water. Okay, so this one I am going to explain. How are you going to bring slides to water? Bring slides to water. How are you going to bring something to water? When we say bring slides to water, it does not mean that you have to immerse the slides in water. Okay? Naglag. Okay, hindi ganon. It's not what is being, or it's not what it meant. Okay? It's not what it meant. It's not what it means. All right. So when we say bring slides to water, you have to do it gradually. You cannot immerse your slides directly to water. Okay? So how do we bring slides to water, ma'am? Actually, when we say bring slides to water, this process in histopath is known as hydration. You want to hydrate your tissue sections. How do we hydrate your tissue sections? By using decreasing. Okay, you have to make use of decreasing, pababa, decreasing concentrations of alcohol. Okay? So you make use of decreasing concentrations of alcohol. That is how you are going to bring the slides to water. That is how the process of hydration is performed in the laboratory. So that means you start with higher concentrations. Okay? So you can probably start with 90% and then followed by 70%, followed by 80% and then 70%. Okay? So that is how you are going to perform hydration using decreasing concentrations of alcohol. So after the lowest concentration, after that, then you can immerse your slide in water already. Okay? So after na naman, yes, after bringing slides to water, you have to immerse your slides in 1% aqueous lithium carbonate for 1 hour. So again, this is actually the significance why you are bringing your slides to water. What is that? What are you talking about, madam? Because of this. Okay? Because of this. 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 Yan. Because of that term, aqueous. So that means the solvent that is used for the preparation of your lithium carbonate is water. Okay? You will not be able to effectively use lithium carbonate if your sections are not compatible to water. Okay, to the solvent that is utilized to prepare your lithium carbonate. Remember, this is an aqueous solution. Okay, and so you have to make your sections compatible to this aqueous solution. All right. Yes. So after washing your slides, after immersing your slides in 1% aqueous lithium carbonate for 1 hour, the next step is for you to wash it in water for 15 minutes. Okay? So wash it in water for 15 minutes. Okay? Yes. So one disadvantage of using your nitric acid formulations or solutions is that it will lead to the formation of a spontaneous yellow discoloration. So the formation or the yellow discoloration rather that is observed, so this is due to the presence of your nitrous acid. Okay? So remember that your nitric acid, it can be converted or it can undergo conversion to your nitrous acid. Okay? And you would be able to know this, you would be able to know if your nitric acid has been converted to nitrous acid if there is a yellow discoloration. Okay? So yellow discoloration, this will further impair the reaction, the staining reaction of your tissue and your tissue components. All right? And there are two ways by which we can remove your nitrous acid. If, for example, your nitrous acid is observable in your tissues or if it is present in your tissues, then you have to neutralize it using 5% sodium sulfate. Okay, so neutralization using 5% sodium sulfate, and then you have to wash it in running water for 12 hours. So if, for example, your nitric acid is present your nitrous acid rather is present in your stock solution, we make use of 0.1% urea. So your 0.1% urea, it can prevent the formation of your nitrous acid. So it can act as a preservative also. Or it can also facilitate the removal of your nitrous acid from your stock solution. Okay, so the stock solution of nitric acid is the pure concentrated form that we have in the laboratory. Okay, so yan. Those are the things that you have to remember for your nitric acid formulations in general. So what are the different nitric acid formulations that we use in histopath? So the first one, we have your decastrous fluid. Okay, so your decastrous fluid, this is useful for the decalcification of nerve fibers, especially if you are going to make use of silver impregnation as the staining technique later on. Okay, so I repeat, decalcification of your nerve fibers for silver impregnation, we make use of your decastrous fluid. Okay, so decastrous fluid has the following components. We have your chloral hydrates, your distilled water, of course, your nitric acid, and lastly, we have your alcohol. Okay, is there an additive in your decastrous fluid? Yes. And what is that? It's your alcohol. Okay, so alcohol is the additive in your decastrous fluid. Okay, another is your aqueous, 10% aqueous nitric acid. So this is utilized as a simple solution. Okay, this is utilized as a simple solution. All right. And then the next one, we have our formol nitric acid. So again, what did I tell you about the names of your solutions? So the presence or the term formol here indicates the presence of your formaldehyde. Okay. So in particular, we make use of 40% formaldehyde. Okay, 40% formaldehyde plus your nitric acid. So in formol nitric acid, is there an additive? Yes, there is. What is that? That's your formaldehyde. Okay, And then the next one, we have your perennious fluid. Your perennious fluid is composed of your nitric acid, your chromic acid, and your absolute alcohol ang nasa inyo. In other references, it is absolute ethanol specifically. Okay? So what can you observe in your perennious fluid? So it contains two additives, right? Yes, right, ma'am. Okay. So since it contains two additives, it is considered to be a slow acting, okay? It is a slow acting decalcifying agent because of the presence of two additives. Remember, what is the function of your additives? Yes, that's correct, to protect your tissues. However, your additives will tend to slow down the decalcification process. Since your perennious fluid contains two additives, it is considered to be a slow-acting decalcifying agent. Okay? Apart from that, your perennious fluid cannot be, or complete decalcification rather, using your perennious fluid cannot be detected by the routine chemical testing that we perform in the laboratory. Okay? Yes, there is a modification of the chemical testing for complete decalcification for your perennious fluid, which I will be discussing later on at the last portion of decalcification. Okay? And then the last one, the last nitric acid formulation is your fluoroglucine nitric acid. So your fluoroglucine nitric acid, this is considered to be the most rapid decalcifying agent. Why? Why? Okay. This is because of the fact that if you are going to look at the components of your fluoroglucine nitric acid, there are two concentrations of nitric acid present. We have concentrated nitric acid, and then the other one is your 10% nitric acid. Okay, and apart from that, the other component that is incorporated in this formulation is fluoroglucine. Fluoroglucine is not an additive. Okay, so that means your fluoroglucine nitric acid contains uh, two concentrations of nitric acid and in the absence of your additive. So that's why if you're going to look at one characteristic of your fluoroglucine nitric acid, it is considered to be the most rapid decalcifying agent. Okay, it is considered to be the most rapid decalcifying agent. Thus, your fluoroglucine nitric acid, it is recommended for urgent work. Okay, since it is a rapid-acting decalcifying agent. Okay, washing of tissues, I think this is the same. Washing of tissues and washing of sections for your fluoroglucine nitric acid is the same as that of the other nitric acid formulations. All right, so I hope you are able to correlate the factors that I discussed a while back as to the different characteristics of your specific decalcifying agents. Okay, so please, you have to be able to correlate so that you don't necessarily have to memorize everything. Okay? Ayan. So, understanding is vital in order for you to make it in histopath. Okay? Actually, in all of your subjects naman, understanding, comprehending the topics is is a priority. It should be a priority. Kasi sa totoo lang, your histopath, I'm actually very happy that the quizzes that you get in histopath, matataas po sila. Yes. I have observed that in your batch, you are really competitive. Okay, which I think is it's a good characteristic of your batch actually. I like the competitiveness of each and every one of you. Yes, I appreciate your efforts in understanding histopath. Even if all we talk about here are chemicals, di ba? Parang halos lahat naman yata chemicals pinag-uusapan natin sa histopath. But I appreciate it when a lot of you get high scores in your quizzes. I'm very, very happy. Okay, yes. Because at least, sabi ko, at least, yan, may mga natututunan sa akin yung mga bata. And I'm very thankful. I appreciate all of your efforts. Okay, yes. So um, hopefully lahat kayo pumasa. Yes, of course. Why not? If all of you deserve to pass, then all of you will pass, definitely. All right. So I will end the video here and then continue with the other, uh, with the other with the other decalcifying agents and methods. Okay, I will be posting another video. Yes, I think dalawang video pa ito. I'm not so sure. Or one video. I want to, yes, I want to, last video na sana yung next. Okay, anyway, thank you so much for listening. I hope you enjoyed. Bye!